Right. Okay, guys. So this is going to be some explanation on Lab 5. So basically, in last week lecture, we have covered on how we can use clock as a control, right? I mean, to control our system. So in our lab exercise today, we'll try to demonstrate that how we can use clock to control our previous design, Verilog design, which we constructed the ALU circuit. Right, so in here, I mean, I've shared with you guys the codes that have been constructed. So this is for the clock code. So it's just a basic, we have the input of the clock, and then sorry, it's not a clock. This is a counter, right? So this is what do you call it? 3 bits counter. So as you guys can see, as the clock is ticking, positive edge of the clock, then the counter will start to count. So it will be increment one by one, right? 0 until 1. And then what happened is that then the clock will be connected to the control code here. So the control code, if you see here, it is accepting 2 bits input, which come from here. So the output is 2 bit, 0 to 1. Then it is accepting the input from the clock. And then from there, based on the counter, sorry, I should name it as a counter. Made a mistake here, so it means I hope you guys are not confused. So this is a counter code, right? And then the output of the counter will be input to the control. Then based on the counter, then we decide what are the output control signals that we want to send. So for an example, right, so this is your ALU code, right? So your ALU code here. So you guys have you see here, I mean, you have 3 operations. Of course, you guys need to modify it into 5 operations, right? Shift left and shift right. So in this case, we have 3 operations. So we are using only bit 1 until bit 2, which is only 2 bits. So that's why I've constructed a circuit that only need, in my case here, so I use the control signal that have 3 bits output. So these control signals, you need to connect it with the control input here. So to select which operations that you guys want to choose. So this is a fundamental, right? So how we can use counter, to control our system. So later in your mini project, you guys going to use exactly the same circuit, but you guys have to modify it based on your project, right? Let's say you want to develop, construct the code for washing machine or any system that you guys want to develop later. Right. Okay, so then what else? Okay, then after you guys completed this part, and then you have to combine it. So in my case here, I mean, I'm combining just a clock and control here, because just want to show you guys example. So but what you guys need to do is that you have to add this code, clock and control, in your ALU code. Then where you have to combine it, so you have to combine it in your top level module in your ALU. So you have to add it here. So you don't have to construct a new circuit, code like this, like 5. So this is, I'm showing you guys example how you can combine this counter and also control signal to develop a whole control unit to control your system. But later what you guys need to do is that you have to add this clock and control into your ALU code. Then you have to combine it in your top level module code. There. Alright, so as you guys can see, I mean, this is how it looks like in the RTL, right? So you have 2 inputs, clock and reset. And then this is your clock code, and then this is your control code, and this is your output ALU control. So this is the one that's gonna go into the control of your ALU, which operation that you guys want to choose or want to activate. All right, and this is how it looks like in your waveform simulation. So as long as the reset is 0, it's not going to do anything. resetting. So when the reset is high, then you start to feed in the counter, and then you can see your ALU control has started to be sent out from your control unit. All right, so I think that is the explanation for lab today. Do you guys have any question?
No, doctor.
Okay, all right. So I'm hoping uh, the explanation is clear to for you guys, so you guys can start and proceed to complete your lab 5. So if you guys see, I mean, like all those labs that we or you guys have done is related to each other, right? So I mean, these are all the basics that I'll try to give you guys to help you guys to complete your mini project. Because if you guys can see in the the portion of the marks, I mean, mini project or will give you or will contribute a lot of marks in your, I mean, total, total marks for this subject. So I'm hoping you guys that you guys do well in the mini project, and you guys really get something out of it, right? So don't just ask code from your friend and try to copy, because this won't help you guys. So I mean, the most important thing for me is that you guys get what are the basic, knowledge and the basic skills that you can gain from this course, which will help you guys later when you guys are going into the industry. Right, so you guys can continue to work on your lab. If you guys have any questions, please let me know.